This is a really amazing event on the second day of class. I mean, we're really thrilled to have you here. I just want to welcome you on behalf of the STEM, our whole STEM initiative on this campus. This is part of the STEM Speaker Series, and I'm, like I said, really excited. We don't get this many students at most of our events, so please keep in mind that we have a lot of different events you can come to. We'll always publicize them, as Wetleys is obviously of major interest right now. And just, we do still have some water, moon tides, and starbursts in the back. But please give your attention to Ms. Wetleys.
Thank you. Okay. Well, thank you, Kathy, and I appreciate the organization that it took to kind of put this together. All I did was say, well, I'll be happy to talk about the eclipse, and then it just kind of took off on its own. All right, so I'm very thrilled to be here to share the excitement with you of Monday's event. That it is fairly rare that you don't have to go very far to see something cosmic like this. So I'm going to share at least what I know. I probably have more here than maybe what we have time for, so I'll try to at least get the highlights for you. But I kind of like this beginning here. This is like the circus coming to town, right? It's bigger than the circus, but I think actually as you read the news media, it's kind of turning into a circus-like event. Okay, so we'll try to prepare through it and get with it. But yes, it is Monday. I hope everybody is aware of the date. So we're all looking for clear weather, correct? Right? All right. Now, the last solar eclipse that was similar to this, you might have heard, actually occurred June 8, 1918. It is a very similar path, and that kind of tells you how often these events actually occur, all right, at least in one place. Okay? All right, but basically this was about 1918. If you want to know, that's kind of the time of Edison. All right, Edison was inventing his light bulb, essentially, out here. Okay. All right, but now, as far as people in the U.S. past 1918, the last one that we experienced, at least in part of the continental U.S., was February 26, 1979. Many of us were around in those years. And yes, and if you do compare that one to now the upcoming one, right, well, on Monday, you see the lower map there for our path that's going to basically cut right through the United States. Okay, now, I was around in 1979. So here I was, a freshman in college, home on break, February, in Indiana. It was really cold outside, okay? So I stayed indoors, and I thanked my mother to help me. She was very eager to say, yeah, I want to rearrange the furniture, okay? So we rearranged the furniture. I was projecting the eclipse through a pair of binoculars. She found an old window screen that we draped over a box, all right? And she helped me document the event. Okay, but now I do still physically have a good memory of this while it was happening. And even when you saw the path of that was mostly in Washington State, Canada. So Indiana barely was covered up by 75%. Okay, the sun was obscured by 75%. But I remember the mid-eclipse, I went outside with my little parka on, right? Went outside, there was snow on the ground, and it looked eerie. It did look different, and it made an impact. Okay, I never forgot it, right? I came back, so yes, that's where I was in 1979. Now, obviously, things have changed a lot since 1979. Okay, so let me share with you here a little bit that I would like for you to kind of think about comparing, comparing the two. Take a quick look. And
visible today over North America for the last time in this century. This is an ABC special live coverage of the solar eclipse. Now, from New York, here is Mark Simon, right?
Good morning. This is indeed a special event broadcast of a genuine special event. The last solar eclipse of the sun over the continent this century. The moon is moving between the sun and the earth, and across a relatively narrow strip of the northwestern United States and central Canada. What you are seeing now is a picture taken from the Golden Vale Observatory, and it's showing the eclipse of the sun over Portland, Oregon. It is approximately 75% or so of the totality. In 13 minutes, it will be a total over Portland, and we'll show you a fantastic sight there. Now let's move 500 miles east to Golden Vale, Washington.
Okay, yeah, now obviously Certainly you could Google this and find the whole broadcast. But now, kind of get that image of what the news broadcast was like in 1979 compared to what you can see on Monday. Right? There's going to be a wide difference there. All right? Okay. Yes. Okay. Actually, yeah, no. Actually, let's see. Let's try. Going to my next one here. I'm sorry, I'm going to bounce around here. This one. Okay. All right. Let's take a look here. All right. That some of the handouts that hopefully you do have access to should have a link on here. The NASA handout should kind of show you that NASA simulation video has done incredible numbers of good videos of saying what will this look like from different perspectives. Okay, so we can play this one. Okay. That you could pretend that you are out on a satellite somewhere, all right, looking back. And would this be better with all the lights off? I'm not sure. You'd be able to see. Okay, that's good. All right. There we go. There we go. All right. Okay, and it is moving rapidly, right? It is moving rapidly across here. The shadow does move at quite a good pace. All right. All right, and basically, yes, kind of other projects that people have done in the past. If these are predictable and known, then they want to chart a flight path, and they want to fly along with the shadow. Right? So you could spend way more than 2 minutes, yes, with that. Okay. Right, so that's the idea. Okay, that you can, and again, you can visualize most of these that way. All right. So that's back to there. All right. Yes. Now we go to. Okay. Now we go to next. Okay. Now, just a little vocabulary. All right. Why do we call it an eclipse? Right? It is Greek, right? And it is being abandoned. All right. So now, before people understood eclipses, yeah, there was a lot of curiosity that there was a scary kind of thing. That in the middle of the day, the sun suddenly goes dark. Right. Okay. So it was very unusual. People didn't like it. Okay. All right. But it is again nothing really magical. All right. That all we're really doing is looking at geometry here, all right, and basically studying shadows, all right, and experiencing the shadows here. So, nice little thing for your kids to do if it is on a sunny day and even during the day of the eclipse. Let them kind of play with some shadows and see what's going to happen with them. But now, one little thing about shadows, if you also pay attention to close shadows, and even as you're making like little shadow puppets, right, on here, what we're going to look for is where is the shadow sharp and where does it start to get fuzzy. Okay, because that's going to bring up some other vocabulary for us. Okay. All right, but now, again, it's all pretty much geometry, all right? And this is a two-dimensional picture, obviously, of what has to happen for an eclipse to occur, all right? That our moon does orbit us, all right, but we orbit the sun. But the angles, all right, the angles make a difference of what these orbits are like. And now, if you have time, when we get to the end of this, Kushida Siva Yogan, our other astronomy instructor, has brought some wonderful demos that if you want a 3D version of this, all right, she will be happy to go back there and kind of let you play with the Earth and the Moon so that you're the god moving this thing around, all right? But because the moon's orbit is inclined to the direction that the sun makes with the Earth, we do not get eclipses every month. All right, so they don't happen that often, or at least as often as you would expect. But when that orbit does kind of wobble around, all right, and it does get lined up, then we are able to get eclipses. And yes, there are two different types of eclipses. When we have what's called a new moon, when the moon is basically in the same part of the sky as the sun, that's our solar eclipse. All right, and when the moon is at a full moon phase, then the shadow of the Earth blocks the moon, and you get the lunar eclipse. All right, and again, here's just kind of another idea that when all of these orbits kind of mesh together, and a lot of mathematics and a lot of geometry gets used here, that essentially, yeah, when these things do line up, that's favorable for eclipses. So when somebody asks me, well, is there an eclipse season? And yes, astronomers do refer to it that way. When these line of nodes, they call it, are all in sync, then they say, yes, that's the eclipse season. Okay, so that's what we call it. Okay. Now, things are not perfect in our nice little world, but essentially when the moon is going around in its orbit, sometimes it's close to us, sometimes it's a little bit further away. So you can actually get different types of eclipses, all right? So when we're looking again at how the shadow, whether it makes a a sharp shadow or whether it makes kind of the fuzzy shadow. The vocabulary that gets used there is the penumbra is the fuzzy part. The umbra is the darkest part. Okay, so when you are looking at maps of this solar eclipse going through, then essentially if you want to be in the narrow path of totality, that means you're under the umbra. You're under the darkest spot. Okay, if you are in the fuzzier part, okay, the outer parts, that's the penumbra. Okay, so that's the outer parts, and that's where you will see a partial eclipse. Okay, and so where we're located here, as far as Raleigh is concerned, hopefully the other handout that's going around kind of shares that. There's a little piece of information on there that says, as far as being located here, staying in Raleigh, you will see a partial eclipse. Okay, you will not be in the path of totality, so you will be in the penumbra, but at least 93% of the sun will be blocked. All right, so you're going to notice something. All right, it is going to look a little weird. Okay, in the middle of the day out there. Okay, but as far as the moon being at different distances, sometimes when the moon is a bit farther in its orbit from us, that shadow of the umbra will not reach the Earth. Okay, and so that's just like holding one finger and a different distance in front. One looks bigger than the other, but if you adjust your distances, it changes size, perspective, and so you get what's called an annular eclipse. So like an annulus, a ring, that it will never be a total eclipse. Okay, so it's only when the umbra can reach the ground that you will see the total eclipse. So that's hopefully what we're going to all see on Monday, at least live streaming and everything from that. Okay, but here's really what happens. Okay, all right, so all kinds of cartoons. All right, thank you. Okay, yeah, next one. All right, now, again, the reason that this is so unique to our configuration here is because basically of the arrangement of where the moon is, where the sun is, and where the Earth is, all right, and what their sizes are relative to each other. Okay, so what I have kind of up here on the board a little bit is I just did the measurements to scale to some extent. All right, so if I get a picture of the sun here on the left, all right, and then come across here, if that is the size of the sun, all right, here is the Earth. Those of you in the back may have to squint, and then there's the moon. Okay, and so the distances, or the sizes of these, are proportional to what they are. They're scaled down. Okay, but now the distance scale is not correct in this room. Okay, that I actually did this little activity with one of my astronomy classes a few years ago for spring fling, and we really wanted to get the distances right. Okay, these are proportional. These distances from the moon to the Earth are fine, but I took this picture of the sun, put it on one end of ETV. I had to put this one 3/4 of the way down ETV on the library side. Okay, so that's how far these really need to have been spread apart in order to get the right proportions to that. So it really kind of gives you a sense of scale. Yeah. Okay. All right. So when you're even just looking at this picture on the screen now, all right, those of you maybe in the back or the back rows, okay, even if you just hold your thumb up, can you cover up that picture? No? Still too big? Still too big? Okay. All right, so that was going to be the idea that when I did a girls' summer camp, we gave them all ping pong balls, right? We said, okay, how far away would you have to be, and where would you put that ping pong ball to cover up that size? Okay. So again, it's these nice proportions that the sun is I gotta get my numbers right here. My sun is 400 times farther than the moon from us, all right? But it is 400 times larger than the moon, right? So that's nice. Mother Nature kind of made that nice and proportional for us, right? Okay, now, and again, you could look up measurements and kind of make your own little scale, and I found out that these little Earth globes from the dollar store, all right, these from the dollar store, basically next to a marble, this is an Earth-Moon size proportion, all right? Very simply, but then again, you'd have to work out the appropriate distances, okay? All right, and you get a bright enough light from your cell phone or something, you can hopefully make some decent shadows there as well. Okay, so it's all about geometry, right? And very nice that we get to have this confluence of events to happen. Okay. Oh, yes, yeah, okay, there you go. All right, okay, now, again, once people observed the motions of the moon, the motions of the Earth around the sun, then they were able to understand the geometry, look at Newton's laws of gravitation, all all right, and actually figure out the math that allows you then to predict these events. All right, so they are predictable. That's how we knew one is coming on Monday. I will be very disappointed, right, if something happens and the math doesn't work anymore, right? Okay, then we'll all be scared. Okay. All right, but basically, all right, that these are all predictable. Now, if you kind of ask why are some of the shadow bands fat and some skinny, well, keep in mind that when you saw the NASA video, the shadow was going over a curved Earth. The Earth is spinning, all right, nothing is static, all right. So when you're trying to project that now on a flat two-dimensional map, yeah, it is going to spread those shadows out. So you can say, yes, I want to go to Antarctica in the year 2021, right? I can be a big fat shadow, right? Okay, but yeah, you better bundle up. Okay. Okay, but now, if you really don't get a chance to be in totality for this Monday event, you really don't have too long to wait, I hope. April, I think that's April 8th, 2024. Look at this map, right? Going to cut across the U.S. Pretty much in the other direction. Okay, so you may not have to travel too far to go hit that one. Okay, but they're predictable. So notice, how many of these do occur, right? And actually, people have figured out these are about an 18-year cycle. Okay, that any one eclipse can occur about every 18 years or so. Okay, but obviously, to get an exact same shadow again, notice that we had to wait from 1918 up to now. Okay, so that's so to happen in the exact same place takes a bit longer. Let's see. Oh, a lot of them do happen to happen over bodies of water. Okay, so don't be surprised you see Eclipse cruises being advertised, right? So get your tickets on the Eclipse cruise to go sail through the shadow. Okay. All right. Okay. Nice satellite view. All right. This is what the shadow should look like when it does hit the Earth. Okay. So again, we can hopefully kind of see. Notice that it's really not a fine line between the umbra and the penumbra like the diagrams show. Okay. But it is kind of a shadow that spreads out, and it's only because these bodies are spherical, right, that it's going to give us that kind of shape. But yeah, they're gonna watch this from space. Right. They're gonna see what this looks like. Okay. Okay. Now, here's what you want to know. Right? This is what you want to know. What am I going to see on Eclipse Day? All right? Okay. And yes, we do apologize that the Eclipse classes were not ready today to hand out, but we're told that they should be available hopefully on Monday. All right, but I'm going to give you some alternatives if you don't get your hands on the Eclipse classes. Okay? All right? Okay, let's see. Okay, we kind of already looked at that one. Let's try the middle one there. Let's see if that will operate for us. Find our sound a little bit.
Now, this is a 360 video, and you can actually pan or drag the camera. So please follow me. Basically, we're here to Google Indonesia, and we've never done this before. We don't know what to expect. But hopefully, this last week, we did a 360 video. But basically, this place is amazing, and what a great place to actually walk. That's
fine. That's fine. Okay. And again, you can probably Google lots of eclipse videos that they're fascinating from all over the world that people do, and I'm sure we're going to have plenty of them to watch after Monday. Okay, but I thought the 360 was kind of interesting. So if you do download this on your laptop or something, then yeah, you just kind of scroll around, right, and you can actually see what they're seeing from different points of view from there. Now, even if we weren't able to do that,
Indonesia, it's a rare spectacle event, total. Now, this is a 360 video, and you can actually pan or drag the camera. So please follow me. Basically, we're here in Google Indonesia, and we've never done this before. We don't know what to expect. So hopefully, this will actually work as a 360 video for a whole solar eclipse. But as you can see, this place is amazing, and what a great place to actually watch.
You might zoom ahead a little bit when you can start to see the video along. Okay. We'll speed them up a little bit, just in the interest of time. There we go. Okay, now there is a reason behind that as well. Right, so yeah, if you are in the path of totality, right, this is the expectation. Now, notice that the sun is not huge like the NASA videos, right? Okay, in other words, it's going to look the same size in the sky that it always does. Okay, so it's still going to be its right, but obviously with it blocked, basically it's twilight everywhere, all right, and the horizon, right, the horizon is lit up. Okay, so basically you could turn yourself all the way around and see what looks like sunrise or sunset, right, everywhere, okay, around that. Okay, now other folks who have been that if you're on a high enough elevation, all right, you sometimes can even see the shadow moving towards you. It's like, here it comes, right? Okay, so it's going to be there. You can actually watch the thing. Okay, now, while this is kind of running here, with obviously the purpose of having eclipse glasses, all right, that anytime, yes, it looks like that, you need those eclipse glasses on. Okay, it's only when the totality is there that you can remove your glasses, and you will not be harmed by that radiation. Okay, all right, so that probably would stop that. Okay, all right, okay. Yeah, go ahead and try that one there as well. Appalachian State University has a strong astronomy program.
Hi, my name is David Sitar.
Appalachian State University. Our goal is to provide the public with knowledge on the rare and exciting astronomical event taking place on August 21st, 2017. There will be a total solar eclipse spanning across the United States. And we want to best prepare you with material on viewing safety, travel concerns, location, and general solar eclipse information.
Okay. So a lot of this might be stuff you have heard before. Let's see if I can find. Yeah, because he's going to talk about filters for your telescopes or cameras. All right. I think if we get here, yeah, there we go.
We'll have the solar eclipse glasses. For example, here at Appalachian State, on August 21st, there will be plenty of these to go around for everyone. There will be events taking place at Sanford Mall. Once again, though, please remember to put the glasses in front of your face, and you can safely look up at the sun, bring the glasses back down, and then remove them.
If you're interested in a less expensive method, you can use many household items.
Okay, let's stop right there. I'll share with that. I'll share the household items. Okay, all right, but what I wanted you to see, though, is when you're using the eclipse glasses, it is important that you don't go up there and look at it, oh, put the glasses on, right? Okay, because the purpose is that they're supposed to filter out the damaging infrared radiation, which is heat, all right, as well as the ultraviolet and really just the bright intensity of the light. Okay, because if you've ever used a magnifying glass to cook bugs on a sidewalk, okay, well, unfortunately, oh, I'm sorry. Okay. Yeah, that you got to keep in mind that your eyes have lenses. All right, so even whether or not you wear spectacles, is your eyes have lenses. So when intense light is coming in, yeah, the purpose of your lens is to focus that energy on your retina. All right, so if it isn't very, very intense, you know that even if you do glance at the sun accidentally, right, it's reflecting off a mirror. In fact, you are temporarily blinded, but we don't want anybody to be permanently blinded because that intense radiation that is coming in by looking at a prolonged view of the sun, yes, will cook your rods and cones, which allows you to see, all right, and it can actually just destroy the tissue. Okay, so it can be more than a sunburn. So that's why putting them on, then looking up, will do it for us. Okay, let's see where we are. All right. Okay, but as far as on some of the handouts, what astronomers also like to do is to kind of break up the event, all right, and saying when you see kind of the code words of contact C1, C2, etc., this is what they mean, all right? So basically, if you're still going to be staying here in Raleigh, you can expect C1 to take place at about 1:16 p.m., all right, so first contact meaning the moon is starting to cover up the sun, starting to take that first little bite out of the sun, which hopefully you did to your moon pies, right? You started out with small little bites there, okay? All right. If you get to a second contact, what that means is now the moon has reached the second or the other side of the sun, Okay, so now we're on the verge of being totally covered. This is where then you will actually see the craters of the moon kind of make the light kind of bounce around a little bit. Okay, so it's not a smooth surface, it's a little bumpy. And this is where the diamond ring effect or these Bailey's beads get called. All right, so it's just sunlight reflecting through the mountains and the craters of the moon. All right, giving you that effect. Then you get to the maximum. That again is where the whole moon is covering the whole sun. We call that mid-eclipse. All right, and that again is where you can safely remove your filters. All right, C3 is now, this is the third contact, if you will, or it's starting to leave the surface of the sun. Okay, and you'll get the opposite side of the Bailey's beads and diamond ring effect. Okay, and then the end of the partial phase will be what they'll call C4. Aha. Okay, so that's hopefully on this page that does say Raleigh partial eclipse here. So you will not see all of these phases here because we are not in totality. So you will at least see C1, like we said, at 1:16 p.m. The maximum eclipse where 93% of the sun will be blocked will be occurring at 2:44 to about 2:45 p.m. Okay, and then the end of the partial phase will occur at 4:06. Okay, so it will be several hours for this to kind of whole thing to take place. All right, so it can be something that so but the totality itself, right, really doesn't last that long. Okay, and especially under the, you saw the speed of the shadow going across. Yeah, it's 2 minutes kind of max. Yes. No, 2:44. 2:44 is going to be the maximum eclipse. Whatever. Yeah. Yeah, as far as I knew, 2 p.m. Okay. So yeah, if you get them at 2 p.m. and you're outside and it's clear, then yes, you'll still get a chance to use them.
About the 1:16
Yeah.
p.m. She's worried about the one.
Oh, the beginning of it. Okay. All right, but there, okay, you would basically be just seeing most of the sun, right? You would still, it would look like that top picture. Okay, so we would just have a little bite out of it. Okay, so in the meantime, while you're waiting. Sure. Okay. Oh, yeah. Her question was, if you don't have the eclipse glasses at 1:16 p.m., that's not going to be detrimental. Okay. Yeah. So good. Okay. All right. Okay. So now here's going to be your alternatives. Okay. That in other words, there's different ways that you can actually view what's going on, and you don't need to physically look at the sun. All right. It's going to actually project through either go dig through your kitchen, find your nice colander. All right, bring out your colander, let the light shine through the little holes, and you're still getting pinhole images, but notice that those are not round holes, they're little crescents. Okay, so you'll be able to see what the moon is doing in front of the sun, just by the way it's going to be blocking the sun through these holes. People have observed this through leaves of a tree, branches and leaves, okay? They make, actually, you can even go very simple, make your own little openings, right? Make your own colander with your fingers, okay? That you can actually project those onto the ground as well. Okay, so yeah, I've actually stolen a support rod from the physics lab, and I'm going to hook up my colander to it. All right, and I'll let it go through there. Okay, so yeah, you get the shadows through those kinds of things. All right. Okay, the next one should give us another alternative. Okay, on the Appalachian video, yes, they were going to talk about pinhole cameras or pinhole projectors, and this is something you definitely can do. Okay. Empty your favorite cereal box. All right, get your favorite cereal box, and all you basically need, all right, is to cut 2 openings. All right, I've got part of it's cut here, part of it's cut here. I did open it up, and to make it a little more easy to see, I put some white paper at the bottom. Okay, now how this operates, notice that the sun is on one side, it has to go through a pinhole. So on one of the openings, I just put some aluminum foil, taped it on there, just got a pin, made a point there. Now you stand with your back to the sun, let the sunlight go through that pinhole, and it will make a bright spot on that white paper inside the box. And here's your viewing port. Right, you just look through there, and you'll be able to watch what phase or how far along the eclipse actually is. Okay. Now, the bigger the box, the bigger the image. Okay. So I do have some of these. I'll go ahead and pass some of these around. But on one of your handouts also, should also give you directions, right, for how these things operate. But just kind of give a look for how these, and it does suggest the bigger the box, the bigger the image will be at the bottom. Yeah. Right. Okay. So Don't be shy, right? Find the biggest box you can, right? So yeah, okay. Now I've actually seen where people will get the boxes big enough. Okay, so I've got my aluminum foil pinhole here. I've got my opening there. If you make the box big enough, you can wear it, right? You can wear it. You can be inside, right? You can be inside the hole. So you got your own little projector. And that hopefully will be a bigger image, okay? Now, all it will be is a spot of light, okay? It will not be the colorful NASA images, okay? It will just be a spot of light, but you'll be able to tell the progress. You'll be able to know how close you will be to totality and so forth. So yeah, the bigger the cereal box, go to what, BJ's or something, get the big box, right, to be able to do that. So those are simple ways, and actually they do suggest that these are the projection methods that are best to use with small children, okay? Because the eclipse glasses usually are floppy, they're too big, they're going to be trying to look at the sun, they can easily slip off, and you don't want them staring at the sun. So the projection methods are usually the safest for the children. And again, if you go back to my 1979 image there, okay, when I was a freshman in college, that's the method I used, okay. I did not have eclipse glasses then, but I enjoyed it thoroughly, and it looks weird outside. It's just weird. Okay, all right, let's see what else we got here. Okay, if you are in the path of totality, okay, you will not see this here, all right, but if you're in the path of totality, there is a phenomenon called shadow bands, and let's see if we can get this video to run. This is kind of interesting. And I don't believe there's any audio with this one. And it says immediately before and after the totality. Okay, we might want to dim all the lights for this one. Sure. Notice anything? Now, you might even mistake that for when you see what, heat kind of going over surfaces. But this is just because the eclipse is happening. And earlier accounts of this, again, people weren't really quite sure what was going on. They said, oh, there are snakes crawling all over, right? Okay, but obviously the contrast is not always that good. They're always very difficult to photograph. Okay, now they're counting down. Yeah, minus 20 seconds. The eclipse. So yeah, these have been observed. So different phenomena. Now, all kinds of theories, speculation, saying why does this happen and why does it only occur around totality? All right. Well, if you come and take a physics class, and we hopefully get to the optics parts of it, then we do think that perhaps there are some interference patterns kind of going on when the light kind of gets going through the atmosphere. All right. So now, this is basically right during the eclipse here as well. So you notice how dark it is. And then when it starts coming out of the eclipse, all right, then we start seeing them again. Okay, so this is one of at least the best examples that I found for doing the shadow bands. Okay, but obviously during the eclipse, the reason you probably haven't heard much about this is nobody wants to look at a sheet of paper during the eclipse, right? You want to be looking at the actual total. So yeah, that's where you set up your remote camera and you let it do the work for you, and then you enjoy it later. Okay, thank you. All right. Okay, let's see what we got left. Oh, lots of people will be taking data during this event, all right? And when the sun actually does go behind the clouds, or excuse me, behind the moon, right, that the temperature will actually drop. And I don't know, about a week ago, the News Observer had an article where they're concerned about all the solar energy that they're going to lose, all the electricity that's going to be blocked, right? Because this eclipse is taking place. And so they're looking at backup things. Okay, should we go to the natural gas? Make sure that everybody's, but everybody's going to be outside. Nobody's going to care if the lights are on, right? Okay, but yeah, we'll be taking lots of data and noticing a temperature drop. So if it breaks this humidity, we will be happy, right? Okay, so we'll be happy for that. Okay, but it's a considerable drop. Okay, so people will be taking measurements. I'm told that university in the mountains, which escapes me right now, that they're going to be sending up balloons, weather balloons, and they're going to be measuring the temperature during the eclipse as well and seeing what data they can have. Yeah. Okay. Okay. And if you are in totality, it will get dark enough that it will look like nighttime and planets will pop out. Right? Planets will pop out. And right about now, yes, Jupiter, which is usually in your evening sky, will be fairly close here. All right, so if you are out even in the evening, when the sun goes down, Jupiter is probably going to be your first bright planet that you'll be able to spot. But it'll be visible. Mars, kind of on the upper right-hand corner. Venus, actually probably may even be brighter than Jupiter. That those will all be kind of lined up in what we call the ecliptic. And if you really want to test your eyesight, see if you can spot Mercury. Now, first of all, how can you tell a planet from a star anyway? Very good. Stars do this, they twinkle. Planets just kind of sit there, right? Okay, so, and that's all a matter of how far away they are, what their reflective surfaces are. Stars are incredibly far away, but their atmospheric effects makes them twinkle. So that's a way you can tell a planet from a star. Okay, but yeah, we'll hopefully be able to see some of that. Okay? Yes?
Is it during an eclipse that the scientists get their best looks at Mercury?
Well, yeah, the question was during eclipses, is that the best time to look at Mercury? Yes, actually it is to actually take some measurements, but for the most part, if Mercury has a kind of elliptical orbit, sometimes before sunrise or after sunset, it's still visible a bit above the horizon. Okay, but you're right, this is now looking kind of straight up through less dense atmosphere, and that helps. But now that reminds me that when people were trying to figure out Mercury's orbit, they noticed it had kind of a weird wobble to it that they couldn't explain. And we know all planetary orbits are dependent upon gravity. So people went looking for another planet between the sun and Mercury to explain Mercury's weird little orbit. They were looking for the planet Vulcan. They called it planet Vulcan, all right? And people who were witnessing back in the 1918 solar eclipse, yeah, people were out there saying, "Oh yeah, there's Vulcan. I can see it." Right? Okay, which could have been anything. All right, but yeah, that it turned out that it was no other planet. It was just the way Mercury's orientation with all of the other planets involved. Now, another thing that actually gets interesting is if comets happen to be around in our solar system. All right, that if there is a comet that happens to be close to the sun, you wouldn't know it unless the sun is blocked by the moon. So if we can catch a comet, I don't think there's any predicted comets at this eclipse, but yeah, that helps. Okay, now there have been reports of animals changing their behavior during totality. In other words, it's getting dark. Okay, so what do animals do at night? Okay, well, they start making their little night noises and getting ready for, but if you're in totality, I mean, I don't know, how does the animal notice that it's only going to last a couple of minutes, right? So yeah, this is my favorite, right? And those of you cat owners, you probably appreciate that, right? Okay, cats don't care, right? Okay, so whether or not, and again, most people, when a solar eclipse occurs, they're again focused on the sun. They're not necessarily watching their animal. But again, I believe people at zoos and different things, they'll be setting up remote cameras to try to observe this behavior, to see how much they can actually document. There was a couple of questions, and you may have seen this in the news. Should I keep my pet indoors? All right, will the pet be harmed if it stares at the sun? Does your dog stare at the sun now? Mine doesn't. I mean, her nose is always to the ground. Okay, so no, you do not have to worry about putting goggles or anything on your dog for that, because if you throw them a treat, they'll be happy. Okay, so whether or not this is set in stone, and people are still observing these things. They're still trying to measure. Okay.
This is going to be available after.
Okay, good. Okay, so yeah, they're trying to tape it so that we can look at it a little bit later. Okay, let's see, what else? Let's see what else we got. There we go. All right, but again, here's the magic, right? This is what everybody's hoping to see. All right, and no, this has not been photoshopped. Right. Does it look like a big old eye staring at you? Could be, right? Okay, so somebody's watching us the whole time. All right, here. Okay, but I mean, this is the magic, all right? Because the sun does have layers to it, all right? And again, because of this magic size-distance relationship, the moon covers up the photosphere, the actual part that you see in the sky, and then the atmosphere of the sun emerges, called the corona, right? And actually, there's a little bit of a chromosphere in there as well. Now, people are going to be studying this like crazy, all right? Because this is not the same every eclipse, all right? The sun goes through different active, inactive phases, all right? And when the sun is very, very active, the corona is all over the place, right? And it looks very dramatic, so something like this. Other times that eclipses have been observed, sun is kind of sluggish, inactive, and there's not much corona there at all, okay? So if you go through history and look at all kinds of total solar eclipse images, the corona is different all the time. Now, this particular part of our sun cycle is we are fairly inactive, because even when I had my eclipse glasses at home, I was out kind of looking at the sun. And supposedly, if there are a lot of sunspots, you could even see them supposedly through the solar eclipse glasses. Okay, but now my eyesight is either bad, or we have very few spots right now, or they may just be too small to see. All right, but it is possible that those eclipse glasses can do that. But again, this is the magic. This is what kind of draws humanity to kind of say, yeah, this is a spectacle. We had a conversation about English students writing essays, right? And if you want to research or kind of do a little Google search of, there's some beautiful essays of how people feel when they experience the total solar eclipse. Okay. All right. Okay. And now this was just going to be a little bit of your quick astronomy lesson, all right? So that you can all go away from here being astronomers. All right. But this is what we mean by having the sun having layers. All right. So the photosphere, the sphere of light, is actually the part that you would draw with your Crayola crayon, right? Say, here's the sun. Okay, that's the surface of it. Okay. The chromosphere is actually the thin layer, right? That actually comes out during an eclipse as well. And if you see the reddish hints, okay, you've got some solar flares and things going on. That's excited hydrogen. Okay. It's glowing in red there. Okay. So that will be visible, okay, that people will be taking with their telescopes and so forth. Okay. All right. Did that go to different one? One more. Okay, there we go. All right. And then the corona is even the outer layer from the chromosphere. Okay, so that's really what is the spectacular part of the eclipse that gets seen. Okay, so again, notice this doesn't look exactly like the other image from that. And as far as taking temperature measurements, all right, the astronomers use spectroscopes to try to say, okay, what gases can we identify here? And if the gases are at a certain wavelength, that means they have matched a certain temperature, all right? And it has been shown that the corona is much, much hotter than the chromosphere or the photosphere. And that raises a big question, why is that so much hotter, right? It's further out. Usually the gases cool as they get out. But we think it's a magnetic phenomenon, okay? Okay, and again, and here's the difference. Okay, here's another solar eclipse, totally different shape of the corona. Okay, and this is where again we're kind of matching it up with how the sunspots behave. Okay, I think we're getting close to the end here. Yeah, let's see what else we got. Oh, we take kind of eclipse images all the time from a satellite. Okay, there is a solar and heliospheric observatory called SOHO for short. And they're up there looking at the sun constantly, all right? But they put up this little block, I think a little arm, okay? And they're able to actually study the corona pretty much all the time. So this is, again, you don't have to stay here on the ground. You launch your satellite and let it do a lot of the work for you. Okay, I think I got one more image of that. Yeah, there's where SOHO caught a comet. All right, okay, the comet was coming close to the sun. And comets, again, have huge orbits. It takes them a long time to come around, but yeah, they're coming in, getting broken apart a bit. And occasionally, they've even witnessed comets get eaten by the sun. Gravity pulls them in, and then they don't come out the other side. Right? So they're just gone. Okay. All right. Okay, now, here's where I stole a lot of my information. All right. that this site here, eclipse2017.org, has tons of information and lots of the things that I shared with you here today. The one handout hopefully that came around where I was able to pull up the information for Raleigh, or if you wanted to say, if I stay home, what's it going to look like on my block, right? You can actually get that Google interactive map. So I'll be happy to. I think there's a, yeah, that link should be on your sheets as well. Okay. All right. Oh yes, definitely.
So after 5 p.m. today, it may take a while for the webcast to process, but we'll have the whole presentation. We'll have a PowerPoint, a copy of what we're working on right now. All the links, we'll have that up by 5. So if you want to copy on this link or take a picture of it, this is a shared folder on Google Drive. You'll be able to access everything.
Is that a T?
It's goo.gl/6w4twd. You can come up after and snap a photo.
Okay, I think I got maybe one or two more, kind of things here. But again, if you wanted to go back into the history, why again people thought these were scary events is because again, the sun went dark in the middle of the day. So the word eclipse meaning abandoned, yeah, that kind of said some bad omens. And there actually is some documentation that kings and things that people got so stressed they died, right? When eclipses happen. So they always got this kind of bad connotation. But yes, back to when you watch that 360 video. Yeah, go to the next slide. That there are lots of traditions around the globe, right, where they think that, well, what was really happening was some dragon or some cat or something, some beast was eating the sun. And so you had to do your job here on Earth to make all the noise you possibly could to scare that creature away. Because you needed the sun. You needed it to grow your crops. You needed it to live. Okay, so that's the reason for their hoops and hollers and banging. I think even at Griffin Observatory, that if an eclipse is happening, it's their tradition. They get out and they bang the pots and pans just to make sure. You never can tell, right? A little insurance there. Okay. All right. And then when you become knowledgeable, you become powerful. All right. Christopher Columbus, by the time they understood that eclipses were predictable, essentially, that he actually used a lunar eclipse to convince the natives to provide supplies. He said, "Oh, if you don't give me supplies, I'm gonna make the moon go away." Knowledge is power, right? Knowledge is power. Okay. All right. And let's see. And again, lots of links here. But if you want to kind of study the history and kind of where some notable ones here. All right. But yeah, here's the one. Some King Henry I died shortly after the eclipse, promoting the spread of superstition that eclipses are bad omens for rulers. Okay. So that was one of the first ones they had. Okay. All right, but I'm willing to entertain questions or anything else that you can think of. I wanted to save a little bit of time, and if you wanted to play with the demonstrations that our other instructor has brought for you. But
we'll have a survey up. So if you go to the Google Drive folder and you get the materials, if you enjoyed today and you'd like to see more events like this, give us some feedback. Give us your thoughts what you would be looking for an event like this. So take some time.
Excellent.
Okay. All
right. But thank you for coming, and hopefully everybody can experience it.